So the next topic I will discuss is dynamic memory allocation in C++. So in C language also we have discussed about dynamic memory allocation. So dynamic memory allocation, actually it is a process of allocation of memory at the time of running of a program. So using three functions like malloc in C language, malloc and calloc and realloc functions, we have implemented dynamic memory allocation in C language, malloc, calloc and reallocate function. So these three functions we have used for implementing dynamic memory allocation in C language. So malloc and calloc, malloc, this is for memory allocation for integers and floating point numbers, and for arrays like arrays and structures we have used calloc function. So for modifying the size, okay, so which is existed previously, so we have used realloc functions. So these three functions we have used as a part of dynamic memory allocation in C language. So on malloc, calloc, realloc functions we have discussed some programs also. Now, so when coming to C++, as far as C++ is concerned, so we need not to require so all these functions here. So using only single function we can allocate the memory. So what is a single function here? New function, new operator. This is for allocation of memory for all types like integers, characters, floating point numbers, arrays, structures, objects, for all kinds of entities, for all kinds of objects. So we can make use of new operator. So for like in C language, so we need not use malloc function for normal variables, calloc for arrays, structures, realloc for resizing the array. Okay. So those are not required in C++. Directly by using new operator, we can allocate space in the heap memory. Okay. So new operator, this is for allocation of memory, and so there we have used which operator? Free function for deallocation. Here we have to use delete operator. Delete operator for this is for allocation. This is new for this is allocation of memory. Allocation of memory, and deallocation you can use deallocation of memory. So I think I need not to explain much about dynamic memory allocation. So already those basic concepts you have discussed in C language. Okay. So even though once again I will explain the difference between static memory allocation and dynamic memory allocation. So static memory allocation is a process of allocating fixed amount of memory at the time of compilation time. Fixed amount of memory. Means once memory is assigned, that cannot be altered. Means suppose I may use a array like this, character C of some 15. So immediately the compiler's responsibility is to allocate 15 cells for this, like this. Like this, it is going to allocate 15 storage locations, each with 1 byte of space. Okay. So what is the drawback of this static memory allocation? Wastage of space is occurred. Wastage of space. When wastage of space is occurred, so you have declared 15 characters. Suppose I may use only 3 characters like this, ABC. So what happens here? Only 3 characters are utilized here. Remaining 12 characters will be wasted. So this is static memory allocation process which is allocated at the time of compilation time. Okay, the main drawback of this compile time memory or static memory allocation is what? The once the size is assigned means that cannot be altered. Okay, so in the future I cannot extend C or I cannot decrease C. So once it is fixed to 15 characters means that's it. It cannot be changed because all these areas are stored in the memory area called stack. Okay, all the fixed amount of all the static variables. So all the memory is allocated at the time of compilation time. Okay, so the variables which are allocated at the time of compilation will be allocated in the stack area of memory. Okay. The memory which is allocated at runtime will be stored at in the memory area called heap area. Means the heap area can be, the size of the heap can be modified. But once the size is allocated in stack, that is fixed especially for static memory allocation. Okay. So now here we are going to see some examples and new and delete operators in C++. So the general syntax of new and delete operators will be like this. Data type, first I will discuss new operator. This is for allocation of memory. Data type, pointer name, pointer equal to new data type. In case of malloc function, so the allocation process, okay, so the allocation process must typecast, means if you are allocating space for integers, means so we have to use malloc typecasting to integer. But in this case, what we can do, data type star ptr equal new data type, means automatically internally the type conversion is performed. For example, data type is equal to suppose integer, ptr equal to something like same ptr I will give, ptr equal to new int. Okay, here this becomes data type and this also becomes what? Data type. So this is a single variable allocation. Suppose in the same way I want to allocate a piece of memory for a floating point number, then you can use float star fptr equal to new float. Here float, this becomes data type and this becomes a pointer of float type, and this also becomes what? Float type. So this is especially for single variable allocation. Okay. So after declaration of dynamic memory, after assigning the memory, so you can assign values to ptr and fptr like a normal variable assignment, like star ptr equal to something like 20 and star fptr equal to 30. Okay, this is a normal variable allocation process. Now when coming to arrays notation, so the arrays dynamic allocation will be like this. Arrays. Okay. Dynamic allocation for arrays. Dynamic allocation for arrays. So dynamic allocation for arrays will be like this. First data type, pointer equal to new data type. So within brackets you specify size. This is just like normal array declaration. For example, data type equal to suppose integer star ptr equal to new int of size is suppose 5 elements. Now what happens here? Immediately it is going to allocate 5 cells like this. This is 0, 1, 2, 3 and this is 4, and ptr will be pointing to this one. Ptr will be pointing to this one. This is a ptr is a pointer, so which is going to point to these locations 0, 1, 2, 3, 4. So by incrementing ptr variable by 1, automatically it becomes a pointer to next variable. Okay, like ptr plus 0, ptr plus 1, ptr plus 2, ptr plus 4, like this. Okay, so this is just like a star ptr plus 0. Star ptr plus 0, this becomes what? It is pointing to this one. So when I say star ptr plus 1, now this will be pointing to this one. In the same way, ptr plus 2, this will be pointing to this one. Like this, it is going to point to each and every element in the array. So this is dynamic memory allocation for a single dimensional array of which type here? Integer type. Suppose in the same way, I have to assign some memory for 5 floating point numbers. How it can be done? For example, data type, so in the place of data type I can use float fptr equal to new data type, that is float with 5 elements. Okay, so this is dynamic memory allocation for single dimensional arrays. Okay, so these are the dynamic memory allocation for 5 integers. So these are dynamic memory allocation for 5 elements. Now what this FPTR is going to contain? So FPTR is going to contain the beginning location of the array. So let us say this is suppose 1432. What is 1432? It is address in the memory. 1432. Now suppose it is integer. Every integer occupies 2 bytes of space. The next memory location becomes what? 1434, 1436, 1438, 1440. Like this, the R elements are stored in contiguous memory locations. 1434, it is the address of next one. 1436, 68, 32, 34, 36, 38, 40. Okay. Now here what PTR is going to return? So PTR is going to return the address of the starting location, the address of the beginning location of the array. So in this case what happens here? PTR is going to return what? 1432. 1432 will be written by this PTR. 1432 will be written by the PTR. Suppose in some cases the operating system may not allocate this requested amount of space. So in that case what happens means a exception is raised. Okay, so exception is raised. Frequently the operating system may not allocate that amount of requested space. So in such cases C++ raises what? So exception. So exception will be raised by the C++ compiler whenever the requested amount of memory is not allocated by the operating system. So in the same way I can use delete function also. So delete operator. So why for delete operator? So the delete operator job is opposite to new operator. So the delete operator actually does not delete any space. So what it is going to return? It is going to return the address of the memory location. Okay. So it is going to return the address of the memory location, the starting address of the memory location to the operating system. Then it is the responsibility of operating system to clean the memory, to deallocate the memory, to free the memory. Okay, the job of delete function is just to return the starting location of the memory. Okay, in this case what is the starting location here? Suppose I may say like this: delete what I can say here? PTR. So delete PTR means what it can return here? It is going to return what? 1432. So this 1432 will be returned to operating system. The operating system is going to deallocate the memory. Once the deallocation is done by the operating system, the same amount of memory will be allocated to other application program. Okay. That means the job of new function is, the new operator is to return the starting address of the array. Okay, in this case what happens here? Integer star PTR equal new int of 5 means it is going to return address of which one? This one, address of 0, address of starting element. So what is the starting address of starting element? 0 is the starting element. Okay, so this is dynamic memory allocation process for single variable and single dimensional arrays. And so we'll discuss some programs on this dynamic memory allocation process. Just you have a look. So you can assign a value into P like this, star P equal to something like 20. Now 20 is assigned to pointer variable. Okay, this is assignment. Dynamic memory allocation. Allocation for a integer. Dynamic memory allocation for a integer. This is what? Assignment of a integer to a pointer. So address I am printing using pointer notation. So if you want to print value, prefix the variable by star symbol. So this is same as a normal variable. Cout content, normal pointer, sorry, P first one is address, which is in hexadecimal format. Content is 20. So this is dynamic memory allocation process for a single integer. Now immediately what happens here? 20 is assigned, so that the 20 is pointed by this P pointer variable. Now in the same way, I will use this dynamic memory allocation process for arrays. Just you have a look. Hash include iostream.h, hash include unio.h. So allocation will be like this. CLR is here, integer star P equal to new integer. Suppose 5 elements. Allocation of space for 5 integers. Allocation of space for 5 integers. For I equal to 0, I is less than or equal to 4, I plus plus. So read the elements by using scene. Say P plus I. print a message here, cout values after assignment. Like this. At the time of reading values, same thing I am using star p plus I, and while printing also same thing, star p plus I am printing. So this is dynamic memory allocation process for a normal 5 integers. In the same way, just you look at the dynamic memory allocation process for double dimensional arrays. So this is regarding dynamic memory allocation for double dimensional arrays. So here I am taking 3 rows and 4 columns, 3 rows and 4 columns, and a character star character array. So this for this I am taking for pointing for double dimensional array dynamic memory allocation. I am taking what character array as a, this is a array of, this is a collection of, this is array of the collection of arrays, single dimensional arrays. Character array equal to new character star. So for I equal to 0, I is less than or I less than or I plus plus, I plus plus. So by the first statement, what happens here? A array is created for 3 rows and 4 columns, and for 4 rows the columns assignment is done by using this loop. For I equal to 0, I is less than or I is less than or I plus plus. Character of array of I is equal to new character of C. Now this is first this one is declaration of double pointer to pointer for array whose capacity is how many rows here? 3 rows. So after creation of a array with 3 rows, I am individually assigning the column sizes, like character of I equal to new character of C, means character of 0 equal to what? Same character of C. For each and every row of this array will be pointing to 4 columns. Character of array of equal to new character of C. For I equal to 0, I is less than or I plus plus, or you can say plus plus I. And after this, after assigning, after creating 4 rows, 4 arrays, I am filling the elements with something like character of I plus 65. So character of I plus 65 means initial value of I value 0, 0 plus 65 means that indicates what? Capital letter. Capital letter, 4 times capital letters will be filled into 4 columns of character array, character of ij. So here what happens here? Integer I equal to 0, I is less than or plus I again. So you can say I plus. Like this, the elements are filled up. First, this is a creation of a double dimensional array with how many elements? With how many elements here? With how many rows? 3 rows. Okay? A double dimensional array is created with 3 rows. After creation of this array with 3 rows, individually I am allocating columns. Character of I is equal to new character of C. Character of character array I have equal to new character C. Means each and every row of character array will be pointing to 4 columns. So here I equal to 0, I is less than or I plus plus. I equal to 0, I is less than, j is less than C, plus j or j plus plus. This is for creating a double dimensional array with the first 3 rows. After creation of array with 3 rows, individually I am creating a array each with 4 columns length. After that I am filling up the elements into double dimensional array. So after that what I am doing here? I am printing all the elements. Finally by using delete statement, delete operator, I am deleting individual rows. Delete character of I means first row is removed, second row is removed, third row is removed. Like that, how many rows are removed here? 3 rows are removed. Just to look at this. So the arrangement will be like this. Just I will show on the board. Just you have a look here. First R equal to 3 and C equal to 4. So here R indicates rows. C indicate what? Columns. So first array is created. Like what is array name here? Character array. Character array. This is a pointer to pointer. Okay. So this will be pointing to what? 4 individual rows. Like character. These are character arrays. Character. Character array. This is first row, character, second row, character, third row, like this. Now this will be pointing to this one. Now individual elements, character star, this is going to indicate what? This is character star 0 of I. Now each one is pointing to which one? A. Because 0 plus 65 I have given. 0 plus 65 means capital A will be represented. Character star of what? 1 comma I. Character 2 of I. Column position is changed. Row position will be as it is. Character star I value like this. This is what? B, B, B. When I value becomes 1 plus 65, 66. Now this one is C, C, C. This is next character like D. These are individual. Here only 3 rows are created, so the last one will not be there. So this will be pointing to this one. This will be pointing to this one. This will be pointing to this one. So this double pointer will be pointing to these rows like character of star of 0, star of 1, star of 2. So it is pointing to starting location, and each and every row in this arrangement will be pointing to these individual elements like character star 0 I. 0 I means what means the I position will be changed according to column. Okay, the row position is fixed here. Like 0, first character is 0, 0, 0, 1, 0, 2, 0, 3. Now this is 1, 0, 1, 0, 1, 1, 1, 2, 1, 3. Now this is what? 2, 0, 2, 1, 2, 2 and 2, 3. Like this. So first of all the double pointer will be pointing to individual rows in the character array. Now each and every row will be pointing to individual columns like this.